Okay, well, hello everybody, and welcome to another presentation of the online ColdFusion Meetup. I'm Charlie Earhart, and I'll be your host for the next hour or so. In this edition of the meetup, being recorded on Thursday, November 10th, 2016 at noon U.S. Eastern Time, we've got Aurélien Deleusière presenting on Load Test 101, Why and Where to Start. And with that, I'll go ahead and turn it over to him. Thank him for coming on, and take it away, Aurel.
Thank you, Charlie, for your invitation.
How'd I
So
do on
it's
that?
my
Did I get it
first.
right? The pronunciation, did I get it right?
Yeah, I was right.
Close enough for
But the
American,
American
right?
accent is always good.
Thank you,
So it's
sir.
my first time presentation online. It's very, very interesting to do this because knowing that we're connecting while I'm sitting in Paris, as you can hear in French, and that the beautiful power of the internet to be connected, all of us together whenever we want. So we'll try to make it attractive without being present physically. Um, so um, just to introduce myself for whom doesn't know me, I'm software engineer. I'm working in web technology. I'm doing consulting, development, architecture, and some troubleshooting. Particularly where I'm proceeding to load test, and I'm the founder of a company that is named Webelian, based in France and in Poland. We're like 50 employees today, and I'm love ColdFusion and CFML particularly, and since '96 now, so it's already 20 years. I'm doing quite other stuff around this, but still CFML is my primary language when I need to develop. So, question about load testing is why should we load test? Um, there is several aspects. There's, of course, the performance purpose, and that's mainly the question I received prior this presentation online in the comment on the Meetup website, and that's basically one of the main concerns we can have for load testing an application. But it's also to have a clear understanding on an application or a set of application. How do they interact with physical resource or virtual resources, depending on the cases? How much CPU you're using? What are the limits in considering your hardware, the memory, whatever network, or the devices you can have on the network. It's also for scalability purpose. So is you can have an hardware design for a traffic that you have today, and you want to um, um, calculate how you're going to grow and how your architecture needs to progress to reach your expectation. Okay, it's the way that you are able to make calculation and predict what is going to happen with the incoming traffic. And one where I think it's important is robustness. And there I would just say that um, really regularly when I discuss with people, we're always considering load testing as I see the chat, yeah, um, as a pure technical test, and in fact is also for me functional test because under load, yeah, okay, I'm going to, sounds good to you, soft spoken. I'm going to, I think it's better now. Um, so it's also functional testing because you can have your application that behave very, very good, and while you're running high traffic, you can have functional errors that appear, and that's one of the main understanding I would like to share with you as the functional test. Um, So where to start? Basically, that depends on your architecture or on the application, the technology you're using. And when you receive a question coming from nowhere, you never know how to answer if your application is going to resist to upload files, or you're uploading files and you see limits. It really depends on your own application. It's why this presentation is really to talk about concept, approach, give you example, and each time you need to do a load test, you need to think about the situation you need to apply it. Basically, you have two approaches. Or you define the limit of your system in the absolute. So it's what we're more calling stress test. So you're pushing your application, increasing the traffic until you see slow response and even crash of your servers. So it gives you an idea of the capacity of your server. Or also the other approach, the other way around, is to estimate traffic and break it down back to the design of your hardware. And we're going to see both of those approach. What I used to do first when I load test an application is to do a scenario I call calibration. Is to see what is the background noise of a server, because it's always happening something on a server. So depend on your need, depend on the application, but you can do that 5 minutes. I think it's a good start. You may want to do more, maybe 1 hour like this, and you go for lunch and you come back and you see the result. That can allow you to identify prior doing the load test. Maybe you have a peak every 5 minutes, okay, and that means maybe you have a cron job running somewhere every 5 minutes. And that's really important, I think, for me to know what is the background activity of the server before drawing any conclusion on the observation you can do. Also, the second point of this scenario is to define the best response time to calibrate your analysis. Okay, it's where you can expect to have the best response time. Then what I do is an healthiness. So there you see we ramp up 20 requests per second during 30 seconds in this little graph. Is to see the picture. So there is 20, but it depends on the application again. Huh? Maybe it's a low traffic, okay, low to medium traffic. Maybe it's 1,000 requests per second for some services. Maybe it's only 10 for others. So again, it depends on your application. There, the intent is to have picture of how your JVM is behaving, memory, garbage collection, how your system is reacting in terms of CPU. Maybe you can observe also the I/O, and that validates also if your application is well configured, responding well, you have no errors in the test you're doing. Again, 5 minute scenario like this, it's what I do before going to the next one. So the stress scenario, that's the one that we all know about, and is the one that basically when you don't need a full campaign of a test, it's basically the only one you need to do. Okay, you ramp up your request per second. So there, every 5 seconds, we increase by 20 something requests per second. And we want to determine what is the maximum capacity of the system, and in terms of response time and stability. Because often when you run this scenario, you're going to reach a limit where the response time is going to be more and longer and longer and longer, and then you see that there's a pooling that is just slowing down the request, waiting for availability from the server. So basically, we can have a feeling of the maximum there around 100 requests per second. Okay. There also, when you're load testing, but we're going to see that in the result from the tool we use, Gatling, that you more looking in a percentile of time variation. Okay, we are going to see that in 99% of the case we're doing this response time, 95% of the case, and that's what is most interesting, because you can have one single code that took longer for any reason, and you should not consider it in most of the cases. Next scenario I used to do is endurance scenario. So basically, I define a timing like 60 minutes, let's say 1 hour, and I divide by 4 the time. So 1/4 I'm going to ramp up to 80% of the maximum we just determined in the stress test case we just saw. And then after during 50 minutes, we're going to run at 80% of this maximum, then 50 minutes to 90% of this maximum, and 50 minutes to 100% of the maximum. And basically, after this test, you can say, okay, the maximum I just felt in the stress case is confirmed, or maybe at 100 you're going to still see some perturbation, so you're going to be more intent to keep 90% of what you define. Okay, they're also doing this because you're reaching the limit of your system. You're also validating the healthiness of your component that you're testing. Okay, under the target load. This one is really interesting. I did it last year. In fact, I used to do this since years, and I met a lot of cases where I saw that the behavior you can define with the endurance and stress test. We just saw a limit of I don't know 100 requests per second. Everything is good. But if you come from 0 to 100 requests per second without any ramping, and basically it's something that is happening when you have a cluster of servers behind a load balancer, you want to upgrade one of the servers. So you take the server out of the pool, you upgrade it, and you put it back in the pool. And it comes from 0 to an high traffic. So this burst scenario is basically to have a very low traffic, like 1 request per second. Then we jump to 10% of the maximum we determine. We go back to quiet mode, 1 request per second, 20%, 30%, 40%, etc. So it allows us to have a vision at the end of this test how the application and the component you're testing are behaving from switching to 0 to an amount of traffic. And that can you can determine that in the previous scenario the maximum was 100 requests per second, but there you can maybe detect that starting at 80% of this maximum, you have response time that are not acceptable because you have an SLA. And you're going to just say, okay, I'm going not to keep 100 requests per second, but 75 requests per second as a maximum. Okay, that can happen also when you have a campaign. For example, for Christmas, you launch a new advertisement about your product, and then you have a lot of people connecting to your website. About Gatling, and maybe before, just to say about the scenarios, there is one I like to do also, but I didn't put that into this presentation. Is the one I call Iron Man, is to run the scenario of endurance during 24 hours or at least overnight. You can detect some memory leak problems, for example, and you want to be sure that your application can survive overnight and you don't have to wake up the level 2 people that need to take care of your production servers. Just saying this. So Gatling. Gatling is a French open source project. I'm not involved at all into this project. I'm just a regular user. I've been using Jmeter since years, and since last year I'm using Gatling. So you can find Gatling on gatling.io. So I have no shares, no interest in this, but it's really, really a cool tool. It's fully built over Java, built on Scala. So it's like CFML finally. It's an upper language over a JVM. It's a functional-oriented language. It's a bit complicated at the beginning, but for what we need to do, it's really interesting, because you can, in fact, write source code to define your scenarios. That's very good. And they use Neti and Akka as frameworks to manage the high performance network architecture of Gatling. So basically, it's one thread is not one request. Is if you know, it's I would make the same difference between Apache and Nginx, where in Nginx all the HTTP requests are broken down into very small piece of action, and the threads just take those action to be done. So there, the threads are not waiting. Basically, when you have one thread, one request, it take the request and wait a lot of time. And that's one of the limitations of Java, to have a lot of thread. So this is one of the key points that Gatling is very, very highly performant. Okay, you can also, the design is you can have several injector on your network. Injector, it's Gatling instances that you can distribute a job to really stress an application if you need. In my case, I never reach the limit, so I always use only one instance of Gatling, basically. Just there is question is how much performance. So the questionnaire, the information received from the guys from Gatling, it's how many requests per second with a single injector on a WS with 16 vCPU. They reach a traffic of 260K requests per second. For me, it's very, very high traffic. I will never test those kind, but it's the kind of number you can expect with Gatling. I'm checking the chat. No, nobody. If you have any question, you can write there, or maybe keep the question for the end of the session. So, okay, we talk about theory for the moment. I would like to propose you a simple example. Let's say we want to build a very, very small application. We want to produce a chain A, B, C, D, Z, like this, a string, because chain in French is string. So it's my Franglish in this slide. We're going to do that by concatenating ASCII characters from 65 to 90, basically, is A to Z. And I do the test locally. I use my MacBook Pro with a VirtualBox with Ubuntu as guest system. I use the last version of ColdFusion 2016 Developer Edition, and I did also some tests on Lucy when I was at the CF camp. And I'm going to show you some source code from now. So First, the very, very small service I want to test. So we have a loop there. We're going to load test this small, very, very small application. I do some uppercase, lowercase stuff just to make it a bit slower to reach the limit I want to show you. Okay. There's something wrong in this source code. Probably the most of you are already seeing it, but let's keep the surprise for a bit later. Into my application.cfc, I just create a service into my application scope by doing a new dummy service, so this one. And within my index.cfm, I write about this service.run method. Okay, so the function that is defined here. Okay, let's see with my browser if the fonts are too small, whatever, so do not hesitate to ask. Oh, so this is the result. So I have my string A to Z, and that's perfect. Okay. Now, how I'm going to use Gatling. In fact, Gatling is just a zip file. You unzip it, and when you have unzip it, you're ready to test. There you have the files coming by default. What is interesting to see here is there's a conf directory where you can tune some behavior of the Gatling, the bin where you have the binaries, and user file is where we're going to create our scenarios. Okay, so there, if I go into the bin, I see that I have two programs. One is Gatling itself, so when you're load testing, and the other one is a recorder. By purpose in this presentation, I'm not going to show this recorder stuff. I think everyone is familiar with this. Is like with Gmeter, is also proposing the same tool that you run a local proxy. You configure your browser using this local proxy, and you're going to record the activity on your website by simulating a scenario. Here I'm going more to focus on simple pages without any scenario page to page, because I'm going to show you after this this first step the usage of a web service and how I can load test a web service specifically. So it's going to be more how I write in Scala directly my my scenarios. So let's run the first. Yeah, sure. Okay, I see Chris. I'm not familiar with Recorder, but maybe I'm the only one. I'm sure you're not. Depend on your need. The documentation on Gatling.io is really good. So have a look on it, and if you have any question, also you can tweet it, or you can also reach me if you need. So if I go there, I have some ready to run. So we're going to do that for 15 seconds, one request per second. So one user in Gatling means almost a request per second. And I run the constant simulation. So I am running an amount of requests per second that is constant from starting point to the end point. So we see the text, the output of the console. We see there that it is the advancement. So every 5 seconds, the screen is refreshed. We see the most important is what is OK and what is KO. And at the end, we have a report saying that the request count was 15, so one request per second during 15 seconds. That's right, we did 15 requests. The min and max response time, so I see it's in milliseconds, so 18 to 50 milliseconds to response. So the average, the mean response time is 24. Standard deviation, mathematics, so it's 7 milliseconds from the mean response time. And there is the percentile I told you, and we're always going to have a look to 95th to 99th percentile. That's the main data, and we're most of the time going to ignore the max response time. And there you can have a response time distribution. Okay, so that's very basic result. You can exploit this if you automatize your load test. You can parse this and get the information you need. So what I saw done already. But there is a wonderful HTML report you just saw a minute ago because it was open in my browser. So Gatling is generating for us this wonderful. I was reading the chat. So there graphically I see that I put a limit on 20 milliseconds because I'm considering that this service should respond with less than 20 milliseconds. 20 to 50 is what is the maximum acceptable for me, and more than 50 milliseconds is something I want to work on. So there I have no response time more than 50 milliseconds. I have the details on the exact numbers we just saw in the console, and there I have some graphs. So the active user is very, very, very stable. So if you say I want like 90 requests per second, it's going to be 90 and not like 92, 88, 91. The kind of phenomena I used to see with Gmeter in previous version. I know that has been fixed. The response time distribution, you can see that 30, 30%, 13% of the response been less than 80 milliseconds, 90, etc. You get the point. And whatever. Okay, there is other graph, and we're going to see others. So just to show you, no, it's team one. ColdFusion. So I run those tests before the meeting. Of course, I'm not going to run 5 minutes. 5 minutes. So the calibration test is this one. So there we're injecting 1 request per second during 5 minutes. It's exactly what we did. So I got almost the same result. Then I have the healthiness, so I'm going to inject 10 requests per second during 300 seconds or 5 minutes. I get the same results. It's really acceptable. I see maximum there, but you know that the 99th percentile is 20, so it's very good result. Okay. Again, now I can do the stress test here. So I'm going to inject 250 requests per second ramping during 5 minutes. So we get this kind of result. Okay, and we see that we have failures. That's normal because we're pushing the system. But there, what is really interesting is we see the kind of errors we get. So the timeout and the connection exception are basically your server is dead and not responding anymore. But what I see is 2/3 of those errors are coming from the fact that I'm checking that the string ABCD to Z really is not existing into the response. So probably here we have a functional error that we need to check. An interesting view on this, so you see when the system start to crash and then it's at the end of the world and it's just dead. You see all those graphs, and you see in red the errors coming more and more. You have another tabs on the top here that is a detail, and the very last graph is very, very interesting. I use it very often into my reports. Is this one? Okay, you see the distribution of OK and KO based on the response time and the number of requests per second, and you can switch off the OK dots to get only the red points and the red dots, and you see that more traffic we have, more errors we see. So basically, if I go back to the source code, there I think you all saw this mistake that my I variable is not scoped by the var keyword. So it means that because it is shared into the application scope, that several requests are sharing and getting at the same moment into this loop and just messing together. So the ABCD is not right in some cases. It's exactly in introduction what I was talking about functional problems appearing with traffic. This problem is simple there, but trust me, it's a real experience with a ColdFusion application where just one single var was missing and was really complicated to find where this error happened. Okay, so after solving this this issue, demo 1 CF, after troubleshooting, we can have a look, and now I see that I still crash my application. Basically, the stress test is what I try to do, so everything is good. But I don't have the ABCD subscreen missing into the body. So we solved our issue with the scoping. And there, now I have solved my functional problems. I can focus on my stress test and try to define what is the limit. Okay, so there I see that around 200, the application start to be not happy. There, if I have a look on this graph, I see the distribution, I see the time, the response time, and I can zoom in to be more precise to try to determine my limit. So there you have the last number in the tooltip, all users 220. And I think we should keep this 220 at the limit and test it again as the maximum limit we want. So what we said is after this stress test, we're going to do the endurance. Yeah, so important what I miss there is you can define also that have a security percentage. You can rip off the maximum you define. So there, this let's say we just keep 200. No, Chris, that's a really good question. I come back to it right now. If you keep 200 requests per second, and I remove 20%. So basically, I say that 160 requests per second is going to be my my maximum. And I test this. So you see the ramping during a quarter of the time, 80%, 90%, 100%. Okay, and everything is acceptable. Some stuff was happening on my server. Again, it's local test, so it's just for demonstration purpose. Okay. So the question of Chris is, what there report related to memory consumption, which would help with memory leaks? I'm a few slides on this, just there. Go back here a minute. No, it will be after. Sorry for this. Yes, but you need to use another tool because Gatling is just a tool to observe your system as a black box. Okay, it's the point of view of the client of your application. So if you want to monitor what is happening on the server, see where the limit, if it is a CPU, if it is a memory, if it is whatever, all the tuning and troubleshooting activity is by purpose out of the scope of this session. But regularly I use Fusion Reactor for that, and that's a really great tool. And I am there in this presentation. I'm just focusing on Gatling. Okay. I want to show you the script now that allow me to define the Scala scenarios. I'm going to share those files, those Scala files on GitHub, on Gist, or whatever I'm going to. I think Charlie, or I will tweet it and share with you. Just to show you how it is. It's not rocket science. There's some stuff that are quite disturbing with functional programming. But there is what we can call a DSL, so you're just describing your simulation. So you call it a constant simulation. So I did this presentation to CF Camp in Munich, in Germany. There you can get this system get property duration is what you see here. The Java options I'm injecting into the JVM with the minus D duration 15, users 1, base cf.local, and then I launch the gatling.sh, taking into consideration this those Java options. Okay, so you get back your system get property like in Java here in your Scala files. You need to convert the types in Scala, so it's integer, but you make a duration from this integer. And what I told you about the burst scenario, when you're injecting from 0 to an high amount, you can have specific behavior, is why into this constant simulation, I remove 5 seconds and I ramp from 1 to the number of users I want to reach during 5 seconds, and then I keep constant this number of requests per second during the time you expected -5. Okay. If I show you the, I don't know, let's say the ramp simulation, it's the same idea. There into the setup, we inject a ramp user from 1 to the number of users during the duration we want. Okay. The description of the scenario is here. Basically, we're saying that we're going to do an HTTP request. We're going to do a get method to this URL, knowing that I have defined first the base URL here. And there is where I'm going to say if the result of one single test is OK or KO. So I can check that the status is 200, the HTTP response code is 200. And I'm going also to check that I find this substring within the body of the response from A to Z. Okay. And that's important to find. I really recommend to put those kind of control into the content. So if you are testing a website, just look at the source code of the page and just take some words that make sense and put them to be verified in what you expect. Be careful that those words are not disappearing from one call to the other. That's all. But I think you know this. Okay, go back there. Let's take a real example I want to share with you is a quotation service. I was working for a customer that is a global large insurance company specialized in travel insurance. They have this kind of architecture, so with a gateway that is basically doing transformation and routing and services that are doing quotation of insurance. Everything is split on 2 data centers, and there's a load balancer in front of the gateway and a load balancer in front of the services. It's a simplification. There's several load balancers, but for what we want to demonstrate today, it's really enough. Everything is stateless. So authentication also is taking into consideration to the gateway. There's a lot of logging that is done here. They use a Splunk to parse the log and have reporting on and monitoring of the application. There's no databases. All the configuration are loaded in memory from configuration files in XML, JSON. It's basically DS11 and in CFML. So when you face this, what you have to test, you can test it as it is, but you can also simplify it. So what I did is to isolate representative architecture of what we saw. So only 2 services, 2 gateway, the load balancer, into an environment that is really identical to the production environment where you want to draw some conclusion. This point is really important. Install the load test agent, the injectors, as close as possible to the component you want to test. I remember a customer that called me and say, yeah, we're testing this application and we're just reaching 100 user per second, and we're looking the resources, the CPU is low, the memory is low, the IO are low, the network is low. Everything seems okay, but we can't go further than 100 requests per second, so please help. Well, my application is sick. No. In fact, he was running the test from his computer to the data center, so he was just measuring the performance of the network between his machine and the data center. So it looks obvious like this, but it happens more often than you think. So really ask question about the network configuration, if you have a DMZ, if you have what are the appliances and devices on your network, to be sure that you understand what you are doing, and try to be as close as possible. Really, really important. You can install the tool. So it was a question of Chris. Thank you for this. To monitor the resources like Fusion Reactor or Mission Control. But you can also do test as a black box. It's really acceptable also. It depends if you want to do only unit test or load test and tuning and troubleshooting. Fusion Reactor, for whom doesn't know, it is really a very powerful tool to monitor. I use it also for regular Java web app application and not only ColdFusion. Or be aware that you have a free tool, Mission Control, that is already installed on your computer, because it's right within the GTK, and you can have a lot of information from it. It's basic, but sometimes it's enough to see the behavior of the garbage collector, for example. So you have a bunch of good information from this. So let's go back to this quotation service from the real example I show you. First scenario. Let me check the chat. Nobody talk. Okay. The load tests are run against one single component. Okay. So first, I'm going to test what is the capacity of the services on one single instance. Main objective is to measure the maximum capacity of one single component and measure the response time at component level. Okay, basically it's the smallest piece we can measure. Then I did measure 2 services for the load balancer. So there, the main objective is to determine the capacity factor, because your network is not the projection is not linear between both. Okay, I mean that if you reach a limit of 100 requests per second on one single component, it doesn't mean that you're going to have 200 requests per second with two components. So there we try to understand what is the overhead of the network. So most of the time I get a 1.9, 1.95, 1.8, depends really of the case, but be aware that your infrastructure have a role into this measure. And also into the response time itself, you have some latency that can be introduced by the network devices. Then the other scenario I did, in fact, is to also test exactly the same scenarios previously, going through one gateway. Okay, and there, by purpose, I want to have the maximum capacity on the service side, because I want to see where is the limit at the gateway component. So if I have only one service behind, most of the case, you should expect to have your gateway that is much faster than your services. So you can even need to have 4, 5, 6 services behind your gateway to test. So again, it depends on your application. And in this case, we will see that the gateway was slower than the services. Checking the time, 15 more minutes. And at the end, you test the whole stack. And there, from this scenario, you can have an order of magnitude for your SLA if you have some. So in these cases, we had an SLA of 350 milliseconds per request. So the initial test campaign, the calibration, everything was good. Then the healthiness, everything was good. Nothing to say particularly on this. You can notice here that the segmentation of the indicators is 100 milliseconds, then 100 milliseconds to 350 milliseconds, and 350 is the SLA we had to focus on. So then in the stress test, we determine a first limit. So you see on the right the capture from a fusion reactor. So there I had a limit of around 100 users. Okay. So from this 100 users, we made the test here with 80 requests per second, so 80% of the maximum we just determined, to check that it was okay. Okay. There, it's another case that's what's really exciting to work on is in October, so 1 month ago now, we had to face the sales of one of the main train ticket reseller in France, in Europe probably. And they did launch the sales of the Christmas train ticket. So what we got as input data from the business is last year. So first step is to gather the existing data. There we ask about how it was last year. So basically we see that we have a brutal ramp up at 6 a.m. and there is no waiting page, nothing. It's just people that knows that the sales are opening on D-Day at 6 a.m. exactly. So they wake up 5 minutes before and they buy their tickets. So the system was coming from almost zero, to 2,000 requests per minute, quotation per minute. And after that, we see other information that are not significant when we see the peak at the beginning. So we're going to focus only on this sudden peak of 2,000 requests per minute. Second step is to challenge the business expectations. So more data you have, more accurate you're going to be. So you can ask about the sales trends, what do you expect there in this situation? The business was expecting an increase of 30%. So basically I took the 2000 requests per minute and added 30% on it. And still this brutal ramp up from zero. The third step is to forecast your traffic. Okay. It's basically if I have 2,600 requests per minute, it means 44 requests per second. That's wrong because you have to correct the linear projection between them. Okay, if you have a number of requests per hour, you can divide by 60 and have a number of requests by minute that can be acceptable. But when you reach a second, you're near to the duration of your processes. So basically, if you say that you're just projecting like this, it means that you expect to always have 44 requests per second, but that's not true. They can be the double, it can be half, but in average on 1 minute is something we measured, and on average on a second, that's true, that is 44. So you have to feel. It's again, there is no rules. You have to feel how is your service, how is requested by your customer, and you need to feel this volatility. And in our case, we said, okay, it's really a spike at 6 a.m. is going to be the highest point of the whole campaign. So let's say that's on a few seconds, it's going to be just a double and we'll be okay. So we're going to challenge our system with 88 requests per second and brutal ramp up from zero. Okay. The fourth step is to size your system. So based on the expectation you did, you need to focus on your architecture. So there is the architecture I found when I started this load test for the campaign. And we did the test, so with 50 requests per second, 60 requests per second, 70 requests per second, to see that at 80 requests per second, we begin to see when we start the test that the response time reached 300 milliseconds. So we begin to feel at 80 that the system begin to have some difficulty to get the ramp up, the brutal ramp up. And there at 90 requests per second per component, not for the whole platform, per component, we see that there is not acceptable considering the SLA. So we're going to keep the 80 requests per second per server. Okay. The gateway capability, we tested also 10, 20, 30, 35, 40, whatever. The conclusion is was the opposite of what we could have expected. So we said, yeah, 30 requests per second, and I'm going to run this test during 30 minutes to be sure. And even there we see that we have a huge peak right in the middle. So was 2 days before the campaign. So we say, okay, let's decrease it to 25 requests per second, 15 minutes, 60 minutes. It was okay, acceptable for the 99th percentile. So let's keep the 25 requests per second. Okay. So back there, once you have designed, you have verified the traffic per component, you need to expect the worst scenario. Okay, so it's the sizing of your system. So the target is 88 requests per second, and we know that the services is 80 requests per second multiplied by 8 services, means 640 requests per second. Okay, no problem. The gateway, 25 requests per second, multiplied by 4, it's 100 requests per second. It's okay, but you need to expect a disaster. What happens if you lose a data center? You have half of your capacity. So the services in this case were still okay, but the gateway were not okay. So we made a recommendation to say, okay, you need to double the number of instances into your gateway. Okay. So just to sum up the approach when you have some campaign to face, so it's, the other way around, not testing your situation, but gathering your data first, challenge the business expectation to adapt the data you gathered, forecast your traffic, size your system, and on the day, just watch what's happened. What is really interesting is we measured the reality there, so I can show you the number we had. So it looks like what we expected. So that's the real numbers now. That occurred on October 13. There we see the peak was 2,700 requests per minute, and we estimated 2,600. Sorry for the numbers for French guys, sometimes complicated. So we've been really aligned with the reality. And if I look at the detail of the number of requests, I can see that we reach 70 requests per second. For design, we did estimated at 88. So it's not really precise, but it's a statistic approach, and that was a good approach that we did validate. Okay. If you have some question about this, so when load testing is usually, and that's going to be the end of the presentation, we do that on major version releases. And most often, and me as a consultant is where customer call me, is a one-shot load testing, or maybe twice a year, once a year. You go there, but in fact, you go, you do the load test, you give your report, you give some recommendation about tuning or some stuff you saw. But basically, the team in place do not take this like a regular activity. For me, you should really integrate it into automated test first. It's really easy to automated tests with Gatling, but with Gmeter also. Gatling is providing a connector for Jenkins, for example. And that's all. That's done. I wanted to thank some guy there, and particularly Stéphane Landel, that is the initiator of this Gatling project, because he supported me preparing this. And also to all of you, because you're using ColdFusion and CFML, and really you make this community so special and so amazing. Thank you for this. I'm sure you're going to have a lot of questions. I don't know, Charlie, how we proceed now.
Okay, I'll go ahead and switch us to the discussion mode so you can see questions as they may come up. Thank you, by the way, for the presentation so far. And if you need to go back to showing it, just let me know and I'll switch it back to the sharing mode. But for now, if folks have any questions that they haven't asked yet, go ahead and fire them up in the chat pod. And in the meantime, other folks go ahead and start filling out the evaluations on the right. Pretty quiet bunch. No more questions. It's pretty unusual. No. There you go.
Yeah. Thank you, Chris. You already asked some questions. So it was a 101 presentation anyway. So I will share the source code of the Scala files. So watch on Twitter, I think. I will tweet it tomorrow. Thank you, Carl. Thank you for.
And we should point out that just as some of the comments discussed, troubleshooting problems is another whole subject. Load testing can help you perhaps find that there are troubles.
Yeah.
Although a lot of people find troubles without load testing. And sometimes load testing can help you determine whether your solutions are going to help. And sometimes you find out that they don't.
Mhm.
And sometimes load testing doesn't adequately mirror what really happens in production. That's its own subject as well. So there's certainly lots more that could be discussed. But as he said,
Yeah,
this is a 101 on load testing in general and particularly on using Gatling. And if you have a follow up, you could certainly offer a
thank you,
follow up
Mael.
talk, or and I could do one, or others here who are attending. Some of you I know might enjoy doing one. So certainly, if anybody wants to follow this up, including you, Earl, feel free. Just let me know.
Yeah, for sure.
To have you on.
We share. So Jonathan has a question there. Does caching skew testing number on a given sample? I'm not sure to
Change
understand the
them,
word skew,
make them potentially invalid.
my friend. Yeah, for sure. There is a very interesting case we can share with Charlie. We've been both of us in CF camp in Munich, and after the presentation, Charlie came to me and say, "Yeah, response time is like 40, 50 milliseconds. We should have a look on what we can improve on this." And we did install Fusion Reactor on it, have a look, and in fact, you know, on the we connected to the ColdFusion administrator and just said that we're not going to reload any templates, CFM templates, and just get them from cache. And we almost double the cut by half the response time. So of course, any caching strategy is always interesting. So that basic caching within ColdFusion itself, from experience, is using a memcache system like EHCache or Redis or Couchbase. Those kind of cache system are really optimizing. That really depend on your application again. So I would not give figures, but often is like magic when you compare while using a MySQL database. De rien, monsieur. Avec plaisir. With pleasure in French.
Okay, well, that seems to be it for the questions and comments. So we can go ahead and stop the recording right at about an hour. Good job getting exactly an hour. And again, thank you for giving the presentation. And if you have a follow up, if you want to go into some particular problem that you solved, that would be a worthy presentation as well. And anybody else listening, let us know. Just go
Yeah,
to
of course.
ColdFusion Meetup site. You can reach out to me there. I have a URL called speak.coldfusionmeetup.com. And then as a reminder to everybody, and as it says at the bottom of the screen, all the sessions are recorded, and I'll get this one on there right after we stop the recording. So with that, I'll say thanks. And just in case anybody might be waiting to ask a question, you might want to hang out a minute, or in case sometimes when I stop the recording, somebody's waiting to ask without it being recorded. So I'll go ahead and stop it.
Yeah.